So in this session, I will take you through a quick overview of the analysis resource. So you already know we have two different sections in the IDB. The first part is the IDB database, which Randy and Nima explained in the morning sessions. So now we will go through the tools part, or we call it as analysis resource. So this is a quick overview. We'll see what all things are available as part of the analysis resource. And all these different tools, different sections will be gone in detail in the coming sessions. So you can still stop me and ask questions if you have, but we'll have another session later in the afternoon and tomorrow where we will go through in very detail through all these different tools. And before I go into the details, I want to stress a couple of things. So first of all, so we have different tools, for example, for the prediction of T cell and B cell epitopes, and there are some analysis tools which help you analyze different peptides and epitopes that you get from your own analysis or your own work or from the IDB. So for the prediction tools, so we developed these tools from the experimentally derived data. So the performance of these tools depend on the quality and quantity of the data that we get. So most of this data we collect from the IDB database itself, which they curate from all the research that's done around the world from different laboratories. So we always encourage everybody to deposit all the data that you have got, positive or negative, deposit in the IDB. So that helps the tools team to retrain the algorithms and improve the performance. So you or your colleagues or anyone have got data, please ask them to deposit it in IDB. That will help us. Second thing, the prediction tools are kind of a screening step. So the first stop should not be the prediction tools. So first, you go to the IDB database part. So if you have a protein or organism of interest, first you go to the database, check if there are already experimentally verified, tested peptides or epitopes in the database. And if you cannot find them, or you want to study more peptides, or you want to find more, extend those peptides or repertoire, then you come to the prediction tools. You do the prediction. So the first step is not the prediction tools, it's the database, and then you come to the prediction tools. And next thing is that the prediction tools are not confirmatory. They are just a screening step. So if you have a large set of proteins or peptides, it can do the prediction and screen, rank the peptides in the order of predicted affinity or predicted strength. So we just predict it based on previous data that we know. So it's a prediction tool. So it's not confirmatory. So if the peptides that we predict, the top peptides that we recommend as probable peptide epitope candidates, you have to test them experimentally to confirm their epitopes. So what we provide are not the final confirmed peptides from these tools. They are just screening step. So you can expect some false positive in them. So their performance is not 100%. They have very good performance, but still they're not 100%. So you cannot expect all the peptides that come top in the list are finally top confirmed epitopes. So they are screening steps. So just keep that in mind. And another thing is, so there are more people working behind the scenes in the team, integrating these things, putting the tools together, retraining the algorithms. So we only few people are here, and I think Austin and Jenny, they didn't get a chance to introduce themselves. They are new members of our team. So there are more people, and we are constantly working on improving the tools. So we look for data. If we get more and more data, we take the data, we retrain the algorithms, and we are constantly trying to improve the algorithms. So as we get more data, more new retrained algorithms, we'll keep updating the tools. So right now it's kind of a once in 6 months we kind of update the tools. So we publish the new tools, new versions of the tools, and we release notes and all those things. So it may not be necessarily you do the predictions this year for a protein using a certain method, and next year you come use the prediction tool. There can be some variations because we must have retrained the algorithm, and this may be a new version. But for historical reasons, we also provide the older version. So in case you want to check, you can use that. But I just want to keep. So sometimes we get this question: oh, I did the prediction, and now when I'm doing the prediction, I'm getting some, slight difference in the results. So that could be a reason. Like, we constantly try to improve the prediction algorithms, retrain, and publish the new updated versions. So now coming here, so these are the major different types of the tools that we have. First of all, we have some prediction tools, T-cell tools and B-cell tools. I don't know which one I should be using. So for the webcast teams, I don't think if I use this one, it will show up to the webcast team, but still, yeah, this is more comfortable. So anyway, so we have the prediction tools for T-cell epitopes and B-cell epitopes, and then we have got some further analysis tools. So right now, I will quickly take you through this, and in the coming sessions, tomorrow I will be going in detail on the T-cell epitope prediction tools, and Bjorn will be taking you through the B-cell epitope prediction tools in tomorrow's session. And later, the session after this, Alex will be explaining the analysis tools. So this is going to be a quick overview with more focus on the prediction tools. So first of all, we have the MSC binding prediction tools for MSC1 and MSC2. And there's a new interface. It's not new. It's been there for 1 or 2 years now. It's an interface. It gives exactly the same results as the MSC1 and 2 binding prediction, but it gives kind of a default thresholds as an idea for the users to make it easier for you to choose what kind of thresholds and what kind of alleles to use. And next one is the MSC processing prediction. So this is binding prediction. There are some tools for predicting the MSC processing, what kind of peptides are generated, processed, and generated from proteins based on different methods called NetChop, NetCTL, NetCTL-PAN. And there are also a couple of tools for predicting naturally processed peptides for class 1 MSC NP and class 2 MSC 2NP. And there are other tools for predicting immunogenicity for CD4 and CD8 T cell immunogenicity prediction. So the major difference for these tools from the aspect of development is that they're trained on different kind of data sets. So for example, this one, the MSC1, the binding prediction tools are mostly from binding data or eluted ligand data, and the immunogenicity prediction for that one will be mostly using the confirmed epitope data. So that's the major difference in the development aspect. And we also have another tool called deimmunization tool. So for example, if you have a therapeutic protein and you know that some part of this protein is generating some immunogenicity, and you want to reduce the immunogenicity of that protein, so you can use this tool. So what it essentially does is it predicts and finds out which residues or which part of the protein is generating that immunogenicity, incorporates some amino acid substitutions, and try to find which substitution can reduce the immunogenicity of that protein. So all these tools will be explained in more detail later. And for B-cell prediction tools, we have got prediction tools, BPPRED, and some other methods which can predict the linear epitopes. And there are a couple of methods called Discotope and ELIPRO, which can predict discontinuous epitopes, B-cell epitopes. And there's one tool called LYRA, which can predict the antibody and TCR, T-cell receptor structure. And coming to the analysis tools, the first one is the population coverage tool. I think there was a question before. So what this tool does is, if you have a set of epitopes and restricting alleles, and you want to know how much coverage you can get in a certain population or the global population, you can input that data, and you can select the desired population and get an approximate idea of how much population this epitope set can cover. So Alex will be going in more detail with that tool later. And another one is the conservancy analysis tool. Here, if you have a set of peptides and you have a set of sequences, and you want to know how much these peptides are conserved in these sequences, so you can use this tool. You input the peptide sequences, input the set of protein sequences, and you can know how much these sub-peptides are conserved in the set of sequences. And the next one is the clustering tool. So suppose you have a set of peptides, and you know some peptides are similar or identical, and you want to group them together or cluster them, so you can use this tool. So we have a new version, we call it cluster 2. So this is used for that, clustering or grouping similar identical peptides together within a large set of peptides. And this tool called RATE, so this tool, for example, in a use case, so for example, you have a immune response data from certain subjects. for some peptides, and you know the allele profile of these subjects, but you don't know which peptide, which allele, or which peptide, which allele is restricting to which peptide. So if you have this data, for example, the allele profile data from the subjects and the immune response data, then if you input both these data together, this tool can find out the probable restricting allele for each of these epitopes, each of these peptides. So that's the tool called RATE. And another one is Immunome Browser. So Nima mentioned about this briefly. So this is actually a visualization tool. So for example, if you have a lot of peptides or epitopes from a protein, you can visualize which part or which region these peptides are coming from. So this is integrated in the IDB database part. Plus, we now have a standalone tool for this one. So if you have a set of peptides and proteins, you input that, you can visualize which part these different epitopes are belonging to, different part of the proteins. So now I discussed this very briefly before, but I just want to give you an idea. Okay. I'm going to focus more on the prediction tools now. So these prediction tools are mostly used for different purposes. For example, vaccine development, cancer, new antigen studies, and all these purposes. So how we develop this? So we use different machine learning approaches, for example, neural network method, to develop the data, develop the algorithm or the method. And we use experimentally derived data for developing the tools, algorithms. So for example, MSC binding data, or eluter ligand data, T-cell assay data. So we get most of this data from IDB itself. Sometimes we generate data specifically for this purpose, and we are providing most of this training data in our database. I will explain that later. So for example, you can see here, this is what we call training data. So you can see the species here, the allele, the peptides, and the measured binding values. And we take this data, input into, use some prediction machine learning method, for example, neural network method, and develop a prediction method or model. And we use this model to predict for new data that comes from new data, and we get the results based on this prediction model. So as I mentioned before, the performance of each of these algorithms is one of the factors that, major factor for the performance of these methods is the quality and quantity of the experimental data that we use for training the algorithm. So for some alleles, what we see is that for some alleles, we have got a lot of data, and we can see that the performance for that particular allele is very high, but for some rare alleles, we don't have much data, so it's tough to get, high performance for those alleles. So now coming to the where you can access this. So tools.idb.org. So idb.org is the URL for the database, and tools.idb.org is the URL for the tools section or analysis resource section. So either you can go directly here, or from the home page, you can see on the top part, you can see a link analysis resource, or on the right-hand side, there are some direct links to some of the major tools. And here you can see an overview. So on the top, you can see 3 tabs: T-cell tools, B-cell tools, and analysis tools. So you can see all these tools here. Plus, so when you click on these links, what you have is the web or online version where you can submit your sequence, alleles, everything on the browser, and you get the results on the browser itself. But along with this, we also have a couple of other versions. So for example, local version, which you can install on your local computer, or API or RESTful interface, where you can submit your queries or submit your sequence, and it sends to the server at our institute, and it processes and sends the results back to you. So I will have more slides later. I will touch on that later. And here, on this tab, you can see some of the data sets, which, as I mentioned before, which we use for training the algorithm. So if you are interested in developing the tools, you have some machine learning method which you want to try using some of this data, you can use that. So this is more interest for developers. Plus a couple of links below, you can see help and contact. So in the help page, if you go, like we have given a lot of tutorials, question answers and everything, so you can refer that. And for each of the tool, we have a separate help page, a kind of tutorial, where you can refer how to submit the data, how to interpret the results and all these things. And contact is help@idb.org, so Nima already mentioned it. So if you have any question, just send an email and we'll try to get back to you the earliest possible. So next one, we'll take a quick walkthrough through the T-cell epitope prediction tool. So you get the link here. Once you click, you come to here, and there are these are the different tools for T-cells. So first, like MSC class 1 peptide binding to binding affinity of class 1 molecules, class 2, and then there's Epitope, and then this processing prediction, and all these tools are listed on this tab, T-cell tools. So now let's go to the MSC1 binding prediction. So this is the interface, the online or web interface for the MSC1 binding prediction tool. So the basic structure is like you provide the sequence, select the prediction method. So we have provided all the different methods here. So the first one in the drop-down menu is the IDB recommended. So we always recommend like that one, prediction method. And I just wanted to touch here. So we recently did a detailed benchmarking of all the available, publicly available class 1 tools. The paper is still under review in PLO's computational biology. So, but what we saw is that the top prediction method, MSC PAN4, it's on IDB. And it gives very high performance. So this shows the AUC, area under the curve. That's a metric that we use to measure the performance of classification algorithms like binding prediction tools. And they get very high performance. I will touch more on this later tomorrow. So once you provide the sequence, select the prediction method. Next part is to select the allele and the length of the peptide that you want to predict. And once you have that, you can provide the email address here. So if you provide the email address, you will get the results, prediction results sent to your email. So if you have a lot more alleles, a lot more sequences, sometimes it can take long to finish the prediction job. So it's always good to provide your email address. So once the job is done, it will send an email with the results. And once you submit the results, submit the parameters, your sequence and allele, this is what you get on the browser. So you can see that this is your input sequence, and you can see the prediction results here. The first column is the allele, and the sequence number, the start and end positions of the peptides, the peptide length, and this is the peptide for which the prediction was done, and this is the prediction method that was used, and this is the percentile rank. So the percentile rank essentially ranks the peptides based on their predicted affinity. So lower the numerical value, the better the binding affinity, the stronger the affinity. So this is, by default, this is sorted based on the binding affinity. So the stronger binding peptides are shown on top. Again, I will be explaining in more detail this later tomorrow. So, yeah. And this is MSC2 binding prediction. So the structure and the procedure protocol are essentially same. Like class 1, you provide the sequences, select the method, select the allele, length, and submit. Exactly same. And this is called Epitope. So this is another interface for the same MSC1 and MSC2 binding prediction. So the difference is that the user is guided through 6 different steps where you provide, like on one step you provide the sequence, next step you select the alleles, next step you select the prediction method, and on the way we will provide you default, recommended parameters. So for example, what threshold I should be using, what alleles, or what lengths are recommended, all those things. And ultimately, on the 6th step, you can see all the different parameters that you submitted, selected alleles, what length did you select, and all this information. And finally, you get a concise result which shows the peptides that are predicted based on your provided parameters. And if you want to get the complete results, you can go to this link and you can get the complete prediction results for all the peptides. Again, I will be touching more on this tomorrow. And coming to B-cell tools, so this tab shows all the different B-cell prediction tools that we have here. Prediction of linear epitopes from protein sequence, prediction of epitopes from protein structure, epitope prediction based on structural protrusion, all these different tools. So first, let's see how. So essentially, the structure, how the tool works is same. You provide the sequence, select a method, and do the prediction. So here you can see antibody prediction using Epitope from linear sequence. So you provide the sequence, select the method, and submit, and this is the result that you get. So here there are two different representation here. So the first one is a graphical representation, and you can see that all the regions that are shown in yellow are predicted to be B-cell epitope. And you also get a tabular form here. And you can adjust the threshold to find different regions whether they change. And compared to the T-cell epitope predictions, the B-cell epitope predictions performance is not so great. There are different reasons for that. First of all, to develop a prediction model for B-cell is more tough based on because there are more factors that influence this, like for example the structure of the protein. So what we recommend is there are different methods that are available. So it would be good if you can get a consensus of different methods and finalize, select the probable region. So for example, this is one method, Chow and Passman, and this Carpus and flexibility, and this is the Epitope. So you do the prediction for all these three methods and select the consensus region. So that will be a better option to go with. And this is T-cell, B-cell epitope prediction structure based. So you can get a PDB ID or PDB file for the structure and input that here in this tool called Epitope. And you can use that information to predict for the B-cell epitope. So here again, like you said so before, there's the graphical information, and the green part shows the positive predicted region. And we can also see the tabular prediction results. And this is the structural view using the JSMOL viewer. You can see the antibody epitope region here in a 3D structural view. So that's about the B-cell prediction tools, and we will be touching on all these tools in detail later in tomorrow's sessions. And now I want to take you to the standalone version. So as I mentioned before, we have three different versions. So right now what you saw is web version. So you submit all your input on the browser, you get the results on your browser or email. But this one is a standalone or local version. So if you have large amount of data, or you want to do something repetitively, or if this is something that you do regularly, it's not convenient to go to the browser and select everything on the menu. In that case, it's always better to go with the standalone. And plus, if you have the information on the web, if you go with the web browser, the information that's sent over the internet is not secure. So if you are working for some pharmaceutical company and you have some proprietary information, it's always better to go with the local version. If you can install on your local machine or in your private network and use it for your prediction. So you can download this from this page. So we have right now we have the local standalone version for all these tools, and we are continuously adding more tools for the local version. So far we have all these tools available, but in future we'll be having more tools available as local version. And so as I mentioned, you can run these tools, these programs on your own local settings. And the advantages are that you don't need internet. You can run it locally, anywhere on your local machine. And very helpful in case of large data sets. And this is free for non-profit and academia. And we provide this to industry on a nominal fee. And we provide good support and everything. And you will get email for every future release and all the support that you need. And if you are interested to get license for your company, you can contact at license. So how you run this? So this for the local version, we have a version only for the Linux operating system. We don't have a version for the Windows or Mac. So you download this, if you are going to try this, remember to run, there's a file called configure, so you have to remember that. Sometimes people forget it and then it won't run properly. If you are planning to use this, remember to run the configure file. And once run, you can choose your prediction method, like predict binding.py, and netmsc pan is the prediction method used here, so you can provide whichever method that you want to use, either recommended, netmsc pan, or whatever it is, whatever that you choose, and provide the allele, provide the length, and your input sequences. So here, the input sequence are provided in the test sequence file. And you get the results like this. So this is like command line. You get the results as standard output. So if you want to take this, of course you will want to. So you can take this output as like, provide an output file like prediction results. And you'll get the prediction results. This is what you get. So the prediction results that you get are essentially same as what you should be getting on the web version. So in case you try and you get something different, there's some issue. Just report it. So you should be getting exact same results on web version and the standalone local version, all the different versions. So you can take this further and you can do all the analysis for the screening, filtering, and everything, all the analysis. And the other version is Tools API or RESTful interface. So this is also run on command line, but the difference is that so all the details like how you can use and sample commands and everything is given here on this page, Tools API. So what this does is that it collects your parameters and the advantage. So it collects your input parameters and sends the sequence and all these parameters to the server at the LJI at our institute. So you need internet. So you can use this on command line, or you can incorporate this in your own scripts or pipeline. But the commands are sent to the server at our institute. The advantage is that you don't have to install anything on your local machine. So if you have just one peptide and one allele you want to, or a couple of alleles, couple of peptides, you can quickly type it and get the result. And another major advantage is that it can be incorporated in prediction pipeline. I'll just show a glimpse of that. And this is freely available to everybody, industry or everybody, freely available. And this is automatically updated. So if you are using the standalone local version, you will have to update. Whenever a new version is released, you will have to download the new version. But for this one, you don't have to worry about it. We will be updating all the versions in the back end of our server. So for example, this is an example. So here you can see that you have a list of peptides and you have different alleles here. So if you go with the web version, you will have to select all these alleles, or you have to provide all these alleles, and and once you submit, these peptides will be predicted for all the alleles that you provide. So you don't need that at first, right? So you have one corresponding allele for one peptide. So you can write a script, and if you do this regularly, you can just write a script, and you can provide these two columns of peptides. You can get the prediction results for these peptide allele combination. So that's one application of this API. And there will be different applications. So for example, you want to make a pipeline which you for your own custom purpose in your company or in your institute, in your organization. So you can make this pipeline, integrate this API command inside your script or inside your pipeline, and you can run that again and again. It will be easier. And here you can see that for this peptide allele combinations, you get the results like this. So those are the three different versions: web, standalone, and API. For the web version, the client uses the browsers to submit the data, and the predictions are run on IDB tool server. It can be run on Windows, Mac, Linux, any operating system, and internet is needed. And this may not be suitable for very large data sets. This is automatically updated, of course. And standalone or local version use command line interface. This has to be downloaded from the IDB website, and you have to install it on your machine. And this runs on Linux only. In case you have Windows machine, you can install the VirtualBox or VMware and install Linux operating system within that VirtualBox or VMware, and then run this tool. Internet is not needed once installed, once downloaded. And this is better for very large data sets, and you will have to update it for every release. And this is free to academia or non-profit. This is a license for industry. And coming to the API or a full interface, this again uses command line interface, or you can integrate using your own script or pipeline. And predictions are run on IDB server. The client sends parameters to IDB server using commands, and you need internet to pass on these commands and parameters to the server. This can be used to make custom scripts for use with large data sets. This is automatically updated and available freely to all. Yeah. So that's a quick overview of the tools and analysis, resources that are available. A couple of points again to remind. First off is the IDB database on the tool, and if you want to study further, come to the prediction tools and go to your prediction. Epitope prediction tools extrapolate from existing data. So we use the experimentally derived data and develop models and use that to predict the new Epitope early prediction. And the machine learning approaches, as I mentioned before, using these different machine learning techniques, we identify different